OK, well, I hope you guys aren't tired of hearing about GraphQL yet. I know that's been a recurring topic around here. But we're going to talk about it in a specific case. We're going to specifically talk about how you can get GraphQL into your existing architecture today, something that currently calling GraphQL over REST. It's specifically for people who have REST APIs, have backends today, and you want to figure out how you can start with GraphQL in the easiest way possible. So first of all, what's Apollo? Basically, we started working on this GraphQL stuff about 2 years ago. And back then, it was a really small thing. You wouldn't come to a conference. Almost nobody would have heard of it. And so we made it our goal to take what we saw as the huge potential of GraphQL and bring it to as many developers as possible, because we felt how revolutionary it could be. And you guys, you all have real work to do. You got to ship those features. And so we want to make it our job to solve those hard infrastructure problems for you so you can get everything set up really nicely. OK, so let's take a step back for a second and talk about GraphQL. How many of you guys have heard of GraphQL in here? Before the conference. How many of you are actually using GraphQL in production? OK, that's kind of what I expected, which is almost everyone's heard of it, but not that many people are using it in production yet. And for those people who haven't heard of it, it's pretty simple. It's basically an API system that you could use to replace REST or similar. And it's built around two things. One is a schema you can use to describe the data that's available in your backend. Looks like the thing on the left. And then there's a nice query language, which is where the QL comes from, that you can use to describe the data you want based on that schema. And use it usually to communicate between your backends and your front ends built with React, for example. But we're at a React conference talking about front-end development. What's the deal? Why are we talking about APIs anyway? And it turns out that dealing with APIs and dealing with data management is currently one of the most complicated parts of being a front-end developer. Because what you're actually building is a distributed system where you've got your backend, you've got multiple services maybe, you've got multiple apps, multiple clients, you're working offline. There's all this stuff you have to deal with that isn't really part of making your app look beautiful and feel great to use, but it's something you still have to do as a front-end developer because that's what you got to do. And so you end up with these funny articles. People really took issue with this title on Twitter, which I love, which is how GraphQL can replace Redux. And the question is, how can an API specification replace a library? Well, it turns out that's not too far from the truth. Because right now, in the front end, you have to deal with all this complexity. You've got to manipulate data. You've got to deal with offline support, normalization, retrying, polling, optimistic UI, reducers, action creators, sagas. But with GraphQL, you don't have to do any of those things, because you can write a GraphQL query, and in one response from the server, and the server does all that heavy lifting for you, or at least a lot of it, you can just describe the shape of the data you want, and you get it right away. And that saves you a bunch of complexity in the client. And that's why, even though it's an API technology, it's really something for front-end developers. And you can see this just from the numbers. One of the things I checked before we talk, one of the tools that we work on is called Apollo Client, which is a GraphQL state management library for React. And in the last 2 years, since we've been working on it, it turns out Apollo Client is now the second most popular data management solution overall for React, behind Redux itself, which is something that almost everyone is using. So definitely, you can actually use it now even without having a GraphQL API at all. We've built in functionality that you can use GraphQL just to manage your client-side data, or you can even call your REST APIs directly from the client using Apollo Client. And because GraphQL is such a great abstraction layer for dealing with data, and you can paper over all kinds of complexity, we want to bring the newest cutting-edge features of React and data management to you as easily as possible. So just recently, if you guys have heard of React Async or Suspense or anything like that? All right, the trendiest people. So just recently, Dan Abramov was talking about a new feature called React Async or Suspense that helps you deal with data management in an application that's being rendered asynchronously. And we've already got support for that inside Apollo Client, because you've got this really nice abstraction. You don't have to worry about anything in terms of managing your data. But I'm not here to talk about that. I'm here to talk about the main other issue, which is you heard about all these things, and you're like, well, what's the point? I don't have a GraphQL API anyway. The real problem is I can't get these things at work. So how do you get a GraphQL API? So the first thing that I always take issue with is that GraphQL is often presented as a big rewrite or a big re-architect of your application. But it doesn't have to be that way. As we talked about before, the main benefits you get from GraphQL are actually front-end development velocity. It's much simpler client-side logic, simpler implementation. And to get those benefits, that velocity, you don't have to rethink your whole architecture. You can get it working in just a few hours, and you can get it running in production in days. As long as you don't think about it as something where you have to start from scratch. Because you've already got an API inside your app. How many of you guys, you folks, have a REST API that you're working with inside your company right now? OK, that's most people. And I assume people that didn't raise their hands weren't paying attention, because everyone's got a REST API. And sometimes as a front-end developer, you're not really allowed to jump in and make changes to that API really quickly. You kind of have to work with what you've got. And even if you could go and rewrite your API, it probably wouldn't be a good idea, because you've got all this business logic that's been built up over years and years. Like, sometimes you don't even know what it does. So the solution, I think, and this is a solution that we've seen work over and over again by talking to people we talked to on the Apollo team, is to put the GraphQL API in between those things. You keep your existing REST APIs. You take your front end, and you put GraphQL right in the middle. That way, we feel you get all the benefits of GraphQL-based architecture, but you don't have to rewrite your backends. From the point of view of the REST API in the backend, it's making more or less the same calls you were making from the front end in the past, except it's taken all that complexity of making all those calls, moved it outside your front end code and into that GraphQL layer, where it's now much simpler to manage. And the front end doesn't have to format data, filter it, or do any kind of management anymore. So let's do a case study with a sandwich. So if you were building a sandwich with a REST API, you might have to make multiple calls for different parts of the sandwich. You probably have to filter them down to just what you want, because I don't know if you ever called the GitHub API back in the day before they moved to GraphQL, but you would get thousands of lines of data back. You would just ask for one repository. You would get every bit of information ever known about that repository. You'd have to filter it down to just the 2 or 3 fields that you want. And worse, you'd have to do waterfall requests from the client, where you get one thing, and then you come back, and then you get the next thing, which would take multiple round trips just to render one part of your UI. But with GraphQL, like if you use the GitHub API today, you can actually put all that in one query, and you don't have to do those round trips from the client. And it actually makes your application more performant, because you're not sending all that data you're not about to use. And this is all true even if you build your GraphQL API on top of your existing APIs. You don't have to make your REST APIs any more efficient. Your app is already going to get better just if you do that. And don't just take it from me. I got really lucky. And yesterday, I stumbled across this article published by a member of the Medium engineering team with also a great title. I love Tokyo Drift is my favorite movie from this series, not of all time. But you can see this diagram is pretty similar to what I've already got in my talk. They've got their React client. They've got their GraphQL server, which, with that dotted line, lives closer to their front-end code than their back-end code. And then they've got their existing services they were already using underneath that. And it worked for them. You can Google this article, check it out. They're going to write another one as well. It's going to be awesome. So basically, GraphQL is changing the game. And you can really increase your development velocity. For some of the teams we talked to, they actually ship their features twice as fast as they could before just by being able to use GraphQL. And so if you're trying to convince your boss why you should be able to use GraphQL, you should show them this handy chart. It outlines the relationship between having GraphQL and your development velocity in a really easy to consume manner, and which I think really makes up for the effort of having to build out that new API layer. OK, so where do we start? Well, we start with the schema. And how do we build the schema? Well, we should think about the API that we want to have to build our app. So let's think about the application that we want to build, and then I'll show you how to decompose that application into the kind of schema you might want for your GraphQL layer. And one thing I want to highlight is that out of the hundreds of teams that we've talked to, we have calls with teams using GraphQL almost every single day. We found the teams are most successful when that GraphQL API and that schema is designed and implemented by the front-end team at the company. So this shouldn't be another one of those situations where somebody else has control over the data you're allowed to access. We believe the right way is for the front-end teams to own that API. So let's see how you would design it. So basically, you can take a view in your app, look at all the fields that are in there, come up with an imaginary query, and you've seen a GraphQL query before, probably. It kind of looks like JSON, but without the actual values. So you can come up with a query that would describe the data you would need to render that UI in the simplest way. And then you can just decompose that query into some of the types you would need in your schema to make that query a reality. And this will work really well for an initial demo. This will get you feeling the power of GraphQL. You probably want to think a little bit more ahead if you're going to be working on it for production. Like maybe you have lots of similar views that need similar data. You want to think about some of them at the same time. But this will get you off the ground real fast. And then you can just use that schema definition that you wrote up to implement the schema directly. So one of the first libraries we ever implemented on the Apollo team was this thing called GraphQL Tools, which actually takes that schema language and lets you make a GraphQL server out of it. Better yet, you can actually mock that schema automatically with just one line of code. So you've come up with your design for your UI. You've written your schema. You want to check if you can actually run that query. You can put this one line of code that's in the bottom left. And then you can open up Graphical right away, which is this interface for running GraphQL queries. And you can check if that query does indeed work. You get back some garbage data that just says hello world, but you're making progress. So before I move on to the next section, which is how to connect it to real data, some tips for designing your GraphQL schema. The first one is don't overgeneralize your fields. Rather than having huge mega fields that take tons and tons of parameters that are basically a query language all their own, stick to simple fields that do what you need. And if you need to do something more general later, add another field. That's the beauty of GraphQL, is that adding another field doesn't cost you anything. Because when you add a field to a REST API, everyone gets it, no matter whether they want it or not. When you add a field to your GraphQL API, people only get it if they ask for it. And you can tell who's using it, because you can use analytics to determine which fields are being called when. The second tip is, one thing you can't do in REST APIs, but you can do in GraphQL, is you can have parameters on nested fields. So if you have a field that maybe needs to have some formatting, for example, a date that you want to represent a certain kind of string, you can actually put that argument right on the field, which is pretty cool. And the last thing, which has definitely turned out to be a best practice over the last couple of years, is don't use the IDs that came with your database. If you can, use a system that has abstracted IDs that are unique across your application. So it's not too hard. You can kind of fake it by just taking the type name and the ID from the database and combining them and doing some sort of hash. But it's better from the point of view of the front end if you don't know what database you're accessing, because the whole point of an API is that it's abstracted. Oh, I skipped my title slide. Now we're going to fill in the data from our REST API into GraphQL. And this is what I always imagine in my mind. This is the first time I've put it on a slide of what it feels like to me to take a GraphQL schema that I've designed and put I kind of think of it as putting my REST API into it. You've got this API that's got some different shapes of data. You've got your GraphQL API you want to fill in. And you keep going until you've filled in the whole thing. So I'm going to show you an example of doing that with a particular API. And the thing that lets you do that is that every field in that schema I showed you on every single type in GraphQL, on your backend, you can implement that as a function. So you can think of GraphQL as a bunch of tiny endpoints, where instead of calling one endpoint at a time, you can call as many as you want at a time. And that function is called a resolver. It can do anything. In this case, we've got a resolver for this cool artists field that returns some of the coolest artists you can listen to today. And so in this case, it's just returning an array. But we can swap that out. Because we can call anything, we can actually call a REST API from there. OK, so this is what it looks like in the simplest version to take a resolver on our schema. And then we can just call fetch to call that REST API. This is probably pretty similar to the exact same fetch call we would make from our client. But we can take that fetch call from our client code, and we can move it into our GraphQL server, which now makes it reusable in all these different types of queries that all the different types of views and clients might want to call. So now that we've implemented that resolver that fetches from our REST API, we can have a hybrid approach while we're working on our API where some of our data is mocked, but some of our data is coming from the real API. So you can see in this screenshot, we've got a real name for the artist and the real Twitter URL, but we haven't yet implemented how to fetch the events. So we're making progress, and like I said, you don't have to go all or nothing. You can build it up incrementally and feel the progress as you're going, rather than writing all the code and then only getting to run it when you're done. So if you go home and try this, it can actually feel like a really cool experience where you're like filling in the data as you go. So now we have to fill in this events field. And this demonstrates that in order to fulfill that GraphQL query that we're doing for our part of your UI, we actually need multiple REST endpoints, right? So we're going to implement something where before we would need 2 waterfall requests from the client, but now we just do 1 GraphQL query. So pretty similar to before, we just call fetch, we put in a URL, we reformat the data a little bit to our liking, because before it was wrapped in some weird JSON wrapper thingy, but now it's what we want. And now we call that query. We've got those 2 resolvers implemented in our server. We get the correct data from the REST API. This is the Ticketmaster API. I didn't mention that, but you can get information about various kinds of concerts and events. Pretty fun, I guess. So now we've got a working GraphQL API that we can use to build that view that we were talking about earlier. One other thing that's really cool is that because GraphQL executes in this fine-grained way, where each field is like a tiny little endpoint, you can actually do analytics and monitoring on your server, taking advantage of that fact. So if you just instrument all of the resolver functions in your schema, you can send all of those to your preferred monitoring tool and create super sweet charts. So for example, in this chart, we can see that this overall API call takes 430 milliseconds to complete. And you can see that breaks down into 200 milliseconds for that first REST API call for that cool artist field. And then the rest is pretty much that events field that calls that second REST API call. And so you can actually tell for every GraphQL query that you write which parts of it cause the execution to take a long time. So again, some tips when you're wrapping your REST API with GraphQL and you're making those fetch calls. I would suggest when you're starting and you're trying to build a proof of concept or a demo, build just enough of a schema for one view of your app or a single query, or maybe just a couple views, so you can get the feel for what it's like to use your data through GraphQL without embarking on a huge replatforming effort. Part 2, if your REST API has permissions built in, which it probably does if you were calling it directly from the client before, you don't have to do anything with those in your GraphQL API. You can just pass them right through and let your REST API handle the business logic and the permissions just like it did before. And part 3 is you need to make sure that you don't make those backend APIs and those databases unhappy. And so I would suggest making sure that the new GraphQL API you've implemented doesn't end up doing more requests to the REST API or the database than your previous client-side fetches did. But you don't actually have to do fewer. It's OK if it's the same level of performance, because the real benefit we're looking for is that developer velocity improvement and removing the complexity from the client. It's been said a lot of times before that GraphQL is kind of a performance hack, but I couldn't disagree more. It's absolutely not about performance, because it's about that developer velocity thing that we've heard from companies over and over again. All right, so last part is you've built out some REST API stuff, you got it working, you saw your data showing up in those queries. What do you got to do to go to production? Well, there's a couple of things you need to consider. The first and foremost thing, which is something you don't have to consider, is that it's not special. Like, GraphQL is just another server. You run it like any other server. You don't need a special system or platform. If you can run Node, you can write and run a GraphQL server. One pro tip we found is that some teams at companies that don't have access to backend code do have the ability to run server-side rendered front ends. So that's a place you can run JavaScript. And you could probably jam a GraphQL server in there. We've seen it before. The other thing is, I think performance monitoring is really important, and we're going to go over that later. Then there's some tools you can do to reduce the number of requests to your REST backend, and then you can also apply some caching to your GraphQL results to make some of your most common queries resolve nearly instantly. So let's look into that. So in terms of deployment, like I said, the biggest thing to emphasize is that you can run it anywhere, you can run any other server. I wrote an article about this last week, so you guys can check that out if you want. One thing I will say is because your GraphQL server is going to be talking to your REST backend, you might want to host it somewhere nearby. That's going to really reduce the cost of any round trips you do between your APIs. So if you're using AWS, you probably want to run it in the same zone or whatever. Look into that. In terms of monitoring, one thing I will say is that GraphQL makes monitoring a little bit more complex. Because a lot of monitoring tools are usually built around the idea of calling an endpoint via HTTP, a URL. And most GraphQL APIs are built in a way where there's only one URL, which is basically /GraphQL. So what you want to do is you want to set up your monitoring so that you can at least see the different queries you're doing separately and time them separately. And what I suggest is there's this part of a GraphQL query, which is just a cosmetic name, which doesn't actually really mean anything. This is where it means something. This is where you might want to name your queries in a way that when you look at your backend later, when you look at your logs, you'll be able to tell which part of your front end made that query that you're seeing in your backend. And the tool that I was showing before is a tool and service that we provide called Apollo Engine, which actually sets this up for you. And it's a GraphQL-specific performance monitoring tool you can check out on our website. So this is a screenshot from that. Next thing that I mentioned is how can we reduce the number of REST API calls to our backend? And so, let's say you were implementing, I don't know, Medium. I bet their schema is more complicated than this. But if you're implementing a feed of posts with authors in them, you might end up with posts that have the same author. And so if you implement your resolvers naively, you might end up calling the same author endpoint multiple times, as highlighted in the middle here, if you have multiple posts from the same author. So you can use this tool called Data Loader, which basically what it does is you give it all the requests you're about to make, and it deduplicates them for you so you can make the minimal number of requests to the endpoints that you desire. And so this is a key tool that you want to use a little bit later on in your journey once you're trying to go to production to make sure that you don't call those APIs too many times. And then the last thing I mentioned is GraphQL result caching. And one of the things you can do, actually, is we've got a spec for cache control built into GraphQL we call Apollo Cache Control. And what it lets you do is actually annotate different parts of your schema with the amount of time that that type of data might be cached for. So if it's public data that doesn't change often, you can cache it for a long time. If it's data that changes frequently, you maybe don't want to cache it at all. But what you can do is you can do the same kind of thing that you would do with HTTP caching of your REST endpoints, which is basically you just don't call the backend at all to execute it again. You just return the result you got before. And that's another thing you can get with this Apollo Engine tool. So last slide. I made it pink so people would wake up. The tips for GraphQL over REST summarized from the whole talk. Step 1, design your GraphQL schema based on your front-end needs. Don't think of it the same way you think of a database schema or your orthogonal backend API. Make it based on what you need for your UI. Part 2 is you can fill in your schema based on data from your existing REST endpoints. You don't need to rewrite your backend. You don't need to rewrite all your business logic. Just use what you already have. And part 3, don't think of over-optimizing it. It doesn't have to be the fastest thing ever designed. It just has to be no slower than your existing front end. And the benefits you're going to get are in the development speed and being able to build new features twice as fast. And you should do it right now, because it's a shame that everyone's sitting here so excited about GraphQL, but almost nobody has gotten the chance to use it in production yet. So I hope that you do. OK, breaking news. I just heard about this today, but we also, if you guys are excited about Apollo Client, I was talking about at the beginning of the presentation, we just launched a new API, which is really trendy because it uses render props. So if you like render props, you'll love this API. You can check it out on our blog. We just published a post about it today. And thank you very much for listening to me.